My name is Michael Brown.
My name is Birender Singh.
And for our project, we used Amazon Web Services with Elastic MapReduce and S3 for the cluster configuration. But I'll go into more detail about how we got those to work later on. But it was basically the same approach Bina did in class, but instead of creating a jar file, we used the streaming program option and provided the Python files for map and reduce. So I'll go into detail later. Our topic was transportation options. So we used, for Twitter and the New York Times APIs, we used these keywords: bike, bus, car, pedestrian, light rail, plane, train, subway, and walk. So then we also grouped some of them together, such as light rail and subway, as well as pedestrian walk, but that's later on in the processing. When it came to the Common Crawl data, our approach was to search using domains that were roughly equivalent to some of the words, some of the keywords. For example, jalopnik.com was the equivalent for the keyword car. For our file structure, here the data collection is stored in the data folder with Common Crawl, New York Times, with the raw articles, or with the raw URLs, and then the scraped articles, as well as Twitter with the full text, and then the grouped data sets. And then the ultimate output from Amazon Elastic MapReduce and S3 is stored in the output folder here, and using the similar file structure. So here's a quick look at the demos we have. This is the visualization for Twitter with bike, and then this is for word count, and then this is the visualization with word co-occurrence. So for this demo, we'll run through the process of using Twitter with the keyword sample. So I'll just run this, configure it to run just on yesterday's states. We already imported the modules, and then run this basically just to collect the tweets first, authorizing the API. And from this, so now we're looking at the raw sample.csv file that we got from Twitter, and this is what we will read into next when we process it. So now that we've processed the sample.csv, nothing actually changed besides just putting it into this grouped folder. Now we go to this my S3 bucket, navigate to input, Twitter, and then we'll put it in there. Okay, so now that we're creating a cluster to run for the sample data. So first we have to configure it using the streaming program steps, and we configure it to point to the mapper that we uploaded, the reducer. These files are here. They basically take input from the standard input, and similarly emit is represented through just print statements. So back to this, we've finished configuration. We've uploaded the sample and pointed to our output directory. Going through this, we set the infrastructure that we want, set the name for it, we'll enable logging. Importantly, we have to enable Bootstrap actions that basically just installs the libraries that we needed. I won't show that right now, but then we will create cluster, and I'll return once this is successfully done. Okay, so now that the cluster has terminated successfully, and you can see the output files here, now we'll go back to our code, and this is for part 3 for actually reading it from the S3 bucket and then processing it. I'll just edit the code to run for the word sample and then return to the video. So here now we are going to download and process the words from the S3 bucket. So here we've went through, processed them, removed any stop words that may have made it past, and then got the 10 largest ones. And then we can see here our sample data is here. This is all the entire raw count, and then this is for the top 10. And then we will turn this into visualization in Tableau. And now here in Tableau, we've brought in the top 10 CSV and made a simple word cloud with the data from sample. And now I will also do the word co-occurrence for that, but it's basically the same process. So in this case, we needed to take the top 10 words from here and make a new mapper specifically for the for this data set with the co-occurrence, and then this just has to be manually changed each time, but we'll upload this to S3 and then run the same cluster configuration, but this time on co-occurrence with the data. Here's the quick look at just the configuration for the cluster. Actually, we needed to change this to word co-occur, but then we will be able to run this then. So actually the cluster won't actually be able to run in time for me to submit everything on time. So we are just gonna take a look real quick at just the co-occurrence code. Basically, once it goes through, it will download the data from this S3 bucket, then it cleans it in order to get rid of duplicates and any stop words that made it past. That's what this code is for. Basically, it takes the pair that is outputted from the MapReduce on Amazon, and then it processes that the pair is outputted as a string, but then we need to parse that and actually have it be meaningful data with the key value pair for the co-occurrence. So we do that, and I'll just show the quick top 10 for pedestrian. So this is the raw pair string that was emitted from the word, and then we've parsed it into like and walk, and then this is just to help with reducing duplicates. So there's not enough time to actually show the sample code, but this is the ultimate end result with the co-occurrence. Hold on, this is just loading. So then you have, so for bike, then you have